Hello, my wonderful viewers. Welcome once again to Frequency Online Maths. Today, we are going to talk about first order linear differential equation. So, what is first order linear differential equation? First order linear differential equation, in our calculus, we used to have y prime, or you can call it the y over the x. This is known as what? First order. Then you have y prime prime, the squared y all over the x squared. This is known as what? Second order, and so on and what? So forth. So first order linear differential equation. So first order linear differential equation comes in the standard form y prime plus p of x y is equals to q of what? X. So when it comes in this standard form, you need to find the function, that's the values of what? The function p of what? X and q of x. So identify the function, the function, the function p of x and q of x. So you need to do what? Identify it. So after identifying it, now you need to find your step 2, find your integrating factor. Integrating factor. So our integrating factor is what? I of x is equals to e raised to the power of integral of what? P of x dx. So after finding your integrating factor, you write your general solution. General solution is y is equals to 1 over our integrating factor times integral, that's indefinite integral of our integrating factor, then times our q of x dx plus c. So plus our arbitrary what? Constant. So this is the general solution. So whenever you have equation of first order, it must come in this standard form: y prime plus p of x y q of x. Remember, this y prime is also what? Dy over what? Dx. So let's solve one example. Example one. Example one. For example, if you have y prime plus 2y is equals to 2 exponential x. So you first of all check whether it's in this form. Are you seeing it? It is in this form, so we can solve it. If it is not in this form, you arrange it to be in this what form. So we are going to identify our p of x. P of x is what? 2, as you can see. Now our q of x is what? 2 exponential x. Now we are going to find our integrating factor. Step 2. Can you see it from there? Finding our integrating factor. So the steps are not difficult. Just understand this finding integrating factor. First of all, identify the function p of x and q of x. After identifying it, you find your integrating factor, then which is integral of p of what? X. If you integrate p of x, it is your what? Exponent e raised to power p of x, it is your what? Integrating factor. So find our integrating factor. So our integrating factor will be I of x is equals to e raised to the power of what? Our this thing, integral of p of x is what? 2 dx. So our I of x will now be integrating a constant. Just attach 2 to the constant x, what you are integrating with respect to. For example, if this thing is 2, the t, it will now be 2t. So this is our I of x. Now using the general solution, y is equals to 1 over our integrating factor, which is e raised to the power of 2x, now times integral of I of x, which is our integrating factor, e raised to the power of what? 2x, times q of x, which is 2 e raised to the power of x, then dx plus c. So our y will now be 1 all over e raised to the power of 2x. Integrating of this thing, if you look closely, you see that we have a constant here because it's not raised to the power of what? X. We are integrating with respect to what? X. So we are going to bring it out using integration by multiplication by constant what? Rule. So we are going to have 2 integral of e raised to the power of 2x times e raised to the power of x dx plus c. So our y will now be 1 over e raised to the power of 2x, then 2 times, we are going to have integral of e raised to the power of 2x plus x. Using indices, the base are the same, you add their powers. So no wasting of time, it will now be 3x dx plus c. I'm still putting the x because we have not integrated. So 2x times 2 times integral of this. If you like, you can use your substitution, but it will waste our time. There's a standard integral that say if you have integral of e raised to the power of ax dx, that it simply means e raised to the power of ax all over this a plus your arbitrary constant. So we are going to use it here. So it will now be e raised to the power of 3x all over 3, then plus c. So this will give us y is equals to, if you multiply, this will give us 2 e raised to the power of 3x all over. We are now multiplying the bracket to this into this will give us 2 e raised to the power of 3x all over 3 e raised to the power of 2x plus multiplying this will give us c all over e raised to the power of 2x. Now, what can you do again? Okay, y is equals to 2 over 3 e raised to the power of 3x minus 2x, right? Because indices, this one will come over. So it will now be x e raised to the power of what? X. Then plus, I think we can use negative indices here. So it will now be c e raised to the power of minus 2x. You understand? Because when you change it, it will now be c times 1 all over e raised to the power of 2x. Still the same thing. So I think this is our answer. So this is our answer. Thank you for watching and may God bless you. Don't forget to follow us on our Facebook page, subscribe on our YouTube channel, TikTok. We have a new TikTok account. Please subscribe on it, please. Bye bye.